This is domain of logarithms. And if you remember with domain, we're looking for all the x values that we could plug in here that would give us a real solution. So what are the possible x's that we could plug in? And what we're looking at right now is what we can't plug in. So if you go back and you remember, if you take a negative and you try to take the natural log or log, it gives you an invalid output. It means it's not possible. If we try it with 0 as well, doesn't work either. So we get a does not exist, does not exist. It's not there. And the reason is, if you have a base of 10 and a result of 0, there is no exponent that you could take for the base of 10 and give you a 0. Even if you plug in 0, you're going to get 1. So it doesn't work. So that's the whole idea. We can't have inside, there's no negs, no zeros. Okay? So no negatives, no zeros means all we can have is positives, which means that inside that we have must be greater than 0. And that's how we find the domain. So x is greater than -2. Just subtract 2 from both sides. And that is our domain. So you just take the inside of the logarithm, make it greater than 0, and solve. Divide by 2, divide by 2. So 3/2. So x is greater than 3/2. Alright. So if we have 2 minus 4x, same thing, greater than 0. And then when you divide by a negative, same rules still apply. You have to flip the inequality. So it's 1/2. So x must be less than 1/2. And then same thing here, x is greater than 0. And you're done. So that's the whole idea. You take the inside, make it greater than 0, and solve, and it'll tell you all the real values that you can plug into your logarithm that'll give you a real solution. Alright, so here is a graph of our function log x. And you can actually see how the log just kind of like it hits a wall. And you notice it's x is greater than 0. There is a vertical asymptote right here at 0 that the graph cannot pass, because it'll never equal 0. That's why this region does not exist. There are no negatives here. And what's actually happening is this. Let's look at a log. So at log of 1, you get 0. But as you keep making the log smaller, it just becomes more and more negative. And it's actually the number of zeros for logs. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. See? -15. -15 decimal places. And that's it. So it just keeps getting smaller and smaller and smaller and smaller. But it'll never actually hit 0. It'll never cross 0, no matter how small it gets. Alright? And then right when you plug in 0, invalid output. And that's the same. I graphed the first one as well, and you can see that it hits the wall at -2. Because everything here has been shifted to the left too. So now when you plug in -2, that's when you get 0, and that doesn't work. So we have a vertical asymptote right here. But there's nothing over there. So whatever the inside is, it can't be 0 or negative. And any value of x that you plug in there that gives it 0 or negative is not going to exist. So that's why we set x plus 2 greater than or equal to 0 and solve, and it'll give us the region that we want.